Okay, so we left off, we had just finished up the p-value method using StatCrunch, which again is just a handy thing to have. And I'm just going to place it in here just for fun. That way I have extra backup for my results above. And then for step 6, you know, if you were going to write it up, you'd say there is sufficient evidence to support the claim that community college students take longer to finish a bachelor's degree. There we go. Okay, so then they also want, that was all part A, believe it or not. Let me go back to the problem. Hold on. There it is. All right, for part B, they want us to construct a 95% confidence interval. So I'm going to show you how to do that. And this is something that a lot of the problems are going to want us to do, but I'm not going to do it every time. I'm only going to do it this once. So, because it's the same method over and over and over. All right, so part A is done. Part B I'm just going to put over here because part A is so involved. It's that hypothesis test. So we need a lower bound and we're going to need an upper bound. Okay, and let's go back and double check that formula. There it is on page 601, and it uses the differences between the means, and then it has a T alpha over 2 and all this other stuff we're going to need to find. So let me go in here. So I guess before I can do the lower bound and upper bound, first thing I need to do is difference in means, which is going to be equal to this minus that, which is 1. Hey, that's handy. And then we're going to need T alpha over 2. Now, I didn't find this before because I was doing a right-tailed test before. But this is going to be a two-tailed thing because it's a confidence interval. Let's see, what level confidence interval did they want? Ugh, I don't have it down. They wanted 95%. Okay, so since they want a 95%, we're going to want, I'm going to take some time here. Alpha is going to be 0.05 because it's 95%. So T alpha over 2 is equal to T dot inverse dot 2T, that alpha. And degrees of freedom, we'll use the smaller of the two, so 268 minus 1. Okay. Now if you're doing old school Excel, you do T inverse like that, and then 0.05, comma, 268, take away 1. Okay, either way. So there's that number, and then the only other thing we need is the big square root. Let me figure it out first. It's big square root for the formula because then I can figure it out. So it's equal to SQRT, and then it was same one we found before actually. It's S1 squared divided by N1, which is 268, plus, and then you do it again. This S2 squared divided by 1145. Close your parentheses, enter. So the lower bound will be equal to that difference, which was 1, take away 1.968 times the big square root we found. And then this other one will be equal to 1 plus 1.968 times the big square root we found. And there we go. We've got our two numbers. Okay, so we found our confidence interval. In fact, I can highlight it. And then they want us to answer whether or not this seems appropriate. So that's part C. Basically, do the results from these two things show that it takes more time for a community college student? So both the confidence interval and hypothesis test support the claim, right? And the reason that you can tell the confidence interval does is because 0 is not in it, right? The null hypothesis was that there was no difference, which would mean the difference is 0. That it takes longer for community college students, probably because they work, right? Probably because there are confounding variables like jobs and work and kids and etc.